last year you studied rationals, which is a fraction. Obviously our fractions have variables in it. Okay, the number one thing we're worried about in a fraction. What's our one problem we could ever face in a fraction with math? Do you remember what the problem was? What's a bad thing with a fraction?
Divided by 0.
0 on the bottom. That's a problem that we always ran into. We do not want that. Okay? What is like the evaluation when you divide by 0? Do you know what you would write? Like if I ever said, what is 5 divided by 0? What would you answer for me?
Undefined.
Undefined. It's an undefined value. Do you know what undefined values graph as? Asymptotes. Okay, so we're going to run into those ideas. So we did this on a reciprocal function, right? Because then, 1 divided by 0, we're making it undefined, so it's an asymptote. Okay, so NPV is going to stand for a non-permissible value. So what is the value I don't want x to be? 2. So the non-permissible value is x equals 2. Okay, what about this one? You don't want x to be 5. So you could have thought about it two ways. Some of you might have said, I'm going to GCF. Or some of you might have just done some algebra thinking. Okay, what about the third one here? What happens when you square a positive number? Positive plus 1, that's still good. What if you square 0? 0 plus 1, that's still good. And if you square a negative number, it's positive. Positive plus 1 is still good. The only way you could create a 0 is if this value was negative 1. Could you ever make that value negative 1? No, because no matter what you square, you can't square something to be negative, right? Does that make sense? So there's none. Everything's permitted. Doesn't matter if we pick a negative, a 0, or a positive. Okay. I think I want to do something to this. What do you want to do to that using your background knowledge? Difference of squares, I heard. So factoring. So x plus 3, x minus 3. Now, what values don't I want to permit? I actually have 2 of them, right? I don't want x to be a negative 3. I don't want x to be a 3. Okay, and the last one, I'm going to do some work to that one as well. So are you recognizing a simple trinomial on that? So multiplies to 14. So 7 and 2, you got to make a negative 5 on it though. So you're not wanting x to be, so a 7 is a not permitted value and a negative 2. Okay, so you're thinking what values make my bottom 0, because then if I had a 0 on the bottom, I'm an undefined value and I'm going to have an asymptote. Okay, so when we have a non-permitted value, they make asymptotes unless there is a cancellation. Somebody tell me, do I want one L or two L's on that word? Two? Does that look right?
That looks way
Too many L's?
yeah.
Well, you can spell it how you want. Cancellation. Okay, so I'm going to show you an example.
It's one L. Cancellation. Oh, no, Zed, you're right.
It's two. Zainab's the English pro. Okay. So here we go. I just gave you an example. So I am not permitted to have what values for x? So I look at the bottom. What x values don't you want? You don't want a positive 7 or a negative 2. Okay, they create vertical asymptotes unless there's a cancel. So this one is going to be a vertical asymptote. But do you notice how this one could have canceled away? So it's going to create a hole. So if I'm graphing, like let's say I'm graphing, I would just draw something like that to say there's a hole there. You got to skip over that value, that x value. So you're not allowed to be that x value, you're not allowed to be that x value, but this one creates a hole in your graph instead of an asymptote. Okay? All right, that is the vertical piece of it. So now we're going to go into the horizontal piece of these graphs. Okay, when you look at this polynomial, do you know what degree it is? What's the degree of that polynomial equation? So your degrees are like, it could be a first degree, a second degree, a third degree, fourth degree. Does anybody know what degree it would be? It's the degree of 3. So why did I pick that? Where did it come from? The degree of 3 is the highest exponent. Which makes the leading coefficient a 2. So the coefficient is the number in front of that. Okay, when you are working with polynomials, okay, let's pretend a cubic is like a lake of water. A squared is like a bathtub of water. And an X is like a cup of water. Okay? When you look at a lake of water, is a cup of water really doing much of anything? Not really. So when we look at polynomials in the grand picture, those are almost irrelevant. Guys, I'm having trouble with my spelling words. Did I spell that one right? I don't think that looks right. Like that. So in the grand scheme, those are irrelevant. Does that make sense? If this is a lake and you throw a cup of water into the lake, not really doing much. Okay. Okay, here we go. Here's your 3 rules. If the numerator, so the numerator is on the top, if it has a higher degree, okay, what happens when your number just gets bigger, bigger, bigger on the top? You're just going to get bigger, bigger, bigger. There's no restrictions. You're just getting bigger. Okay, I'm going to jump to the third one there and then back to the middle. This time, your degrees are bigger. You have a higher degree on the bottom. This time you have a higher degree on the bottom. What happens in math if your number on the bottom gets bigger? So for instance, like a number like that, if the bottom is bigger, what is that getting closer to? If the bottom just gets bigger and bigger and bigger, your number gets closer to 0. So I'm going to be having an asymptote at y equals 0. Because I'm saying this height number is getting closer and closer to 0. Okay, what if the degrees are the same? So the same degree. So this is just an x, this is just an x. So they have the same degree. Then I'm going to divide the coefficients. And this is where your lake bathtub kind of come into play. So pretend I have 10 billion divided by 5 billion and 2. Do you see how irrelevant the 2 is? So what is 10 billion divided by 5 billion? What is 10 billion divided by 5 billion plus 2? What number is that really close to, or basically essentially at? 2. Okay, so if they're the same, you divide the coefficients, and this is kind of the idea. All right, here we go. Let's apply all those rules. All right, first thing I'm going to do is factor. Can you factor the bottom piece? Okay, so x plus 5 and x plus 3. Okay, non-permitted values. What x values am I not allowed to have? -5 and -3. Okay, those values right now are asymptotes unless there's been a cancellation. Has there been any cancellations? Yes. Okay, so this one is a hole, and this one is a vertical asymptote. Okay, so I know I'm going to have a vertical asymptote, x equals -3, and a hole is this, which is called a point of discontinuity. That's a hole, right? A point of discontinuity at x equals -5. Okay, now horizontal asymptote. What do you think about our fraction? Are we a higher degree somewhere, or are we the same degree? We have a higher degree on the bottom. So what do we know about numbers? If the bottom gets bigger, what are we going to get to? 0. Okay, so I'm going to plot my two asymptotes. So I have a vertical asymptote at -3. It's hard for you to probably see my black pen. And I have a horizontal asymptote at 0. Okay, now I'm going to pick a couple points on this side of it, and I'm going to pick a couple points on that side of it. Okay, so I'm going to go -2, -1, and 0. I'm going to plug in those values. And then I'm going to go -4, -5, and -6 and plug in those values. So I'm picking a couple points on the right of it and left of it. Okay, now this is the equation I'm going to plug into. Does anybody see where that came from? Because that's not our original equation. What did I do to have that? Because I canceled those, and after I canceled those, it simplifies to this, okay? You can plug it into the original if you want. It's going to come out to the same thing, but why not plug into something simplified, right? Okay, ready? What do you get when you plug in a -6? 1 over -3. What happens when you plug in a -5? 1 over -2. Plug in a -4. The bottom is 1 over -1. Or in other words, just -1. Okay, plug in a -2. The bottom is 1. Plug in a -1. Then the bottom is 2. Plug in a 0, and the bottom is 3. Okay, so we're going to plot them. They're going to make patterns. So -2, comma 1. -1, comma 1/2. 0, comma 1/3. Okay, I'm going to fill in the pattern. What's going on? And do you remember what to do along asymptotes? You have to approach them, but do not touch them or cross them, or don't curl away from them either, right? You remember those kinds of ideas? Okay. Now we're going to graph the other side, but there's something about the other side I got to remember. Did we remember this? I'm going to have a hole in my graph. So this coordinate 5, -1/2, I'm going to like extremely put it on there. It's a pretty big, but I'm going to draw an open hole there. Okay, and then -4, -1, 6, -1/3. But do you see I'm going to have an open hole there? Okay, so I'm going to shoot down, and then the left I'm going to flatten out. That's it. That's how you graph them.
So you just draw it like a circle then?
Just an open circle like that. Yeah, that means it's a hole in your graph. Okay, I'm going to do one more, and then I'm going to let you try some. So why don't I try the next page? Okay, tell me what the non-permitted value is for x. I don't want x to be, what's the value? 1. Is it an asymptote or does it cancel? It's an asymptote. So it's a vertical asymptote, so that's what the VA, vertical asymptote at x equals 1. Okay, horizontal asymptote. I'm going to analyze my fraction. What do you think? Is the degree higher somewhere or the same degree? It's the same degree, right? I have an x and an x. It's a degree of 1, a degree of 1. So what's the rule when the degree is the same? It's going to be a 5 billion divided by a 1 billion kind of idea. So, therefore, we're going to have a horizontal asymptote at 5. Okay, so now I'm going to get to my plotting, but do you have a sense of what x values you would start with? So because my asymptote is here, I'm going to want to pick probably 2, 3, 4. I like to pick a few on that side of it, and then I'm going to pick a few on that side of it. Okay, so that's what I'm doing there with that chart. Pick a couple x's on this side and then on that side. Okay. You ready? Plugging in a -2 makes -10 over -3, which on a graph would be like 3.3. -1 makes a -5 over -2. So on a graph, that would be a 2.5 number.
Where are we getting to values from?
I'm plugging in a -1. So what do you get on the top here when you 5 times -1?
Oh, no.
And then -1 subtract 1.
Okay.
Do you see the numbers? I'm just plugging in. So then when I plug in 0, what is that? Just boom, like that. 0, because the top is 0. Okay, plug in a 2 makes the top 10 and the bottom 1. Plug in a 3 makes the top 15 and the bottom 2. We okay? That's a 7.5. Plugging in a 4 makes the top 20 and the bottom 3. What do we get there? Should we do 6.7? Is that okay? Because when you're graphing, you don't have to go to 3 decimal places, right? Everything else in this course is always 3 decimals, but obviously I'm not going to graph 6.666 versus 6.7 on a graph. Okay. I don't have any holes to worry about, right? So I'm going to plot and fill in. So I'm going to start here at 210, 3, 7.5. So I did the right-hand side. Do they make a predicted shape with your asymptotes? It's usually like kind of a similar shape. Okay, and then going to the other side.